I think maybe we should proceed. Thank you so much for being here. This is a great crowd. This is, yeah, I just never know. This is my first time in ECIP, so I didn't know what to expect. I'm very happy and excited about everything that's happening. So we have a little, very interactive presentation here. I have a couple of slides, but really this is more about the exercises. And we are going to use the Binder notebooks. Title of our workshop here is Fairness with OPeNDAP, and it's being presented by myself, Miguel Jimenez, and James, who's here. James Gallagher, the President CEO of OPeNDAP, and we have our helper, Chris Batista, here, and then again the ECIP team. I'm going to jump a couple of slides really quickly because this is all about interactive. And let's see. I think I want to show this, and can everybody show the URL on the top? Because that's what we're going to use. Everybody has a computer. We're going to run some notebooks on the browser. We can go through, in a bit, we maybe be able to go through some introductions and can show. This is a little, so I'm just going to type it. Can you see my browser? Yeah. So let's just do, so this is what you're going to look like here. I'm saying this at the beginning because you just never know with Binder. I'm a big user of Binder environments. You just never know. Sometimes they take some time to load. So what I recommend is just to go to the GitHub repository. I don't think you need an account for GitHub. You can just go here, and all you're going to need is to click the Binder button to trigger the build, and then you'll be able to essentially run everything that I'm going to talk on the browser. This is very Python oriented. I'm not sure if you guys want to raise your hand if there's Python users here. Yeah, that's a good number, I think. Yeah, that's great. All right, so it built really fast, so that's good. That's good news. We'll come back to that. But I'm aware that it might take some time for some folks. So this is just for early in the morning. It took about 10 minutes to get to that part, so you just never know. All right, so I'm Miguel. I'm a computational oceanographer. I did my PhD in University of Washington, and then I did a postdoc at Johns Hopkins. So I kind of became a bit of an intersection between computer sciences and oceanography, and I'm here working for OPeNDAP. I'm a scientific community director. So this is the kind of stuff that I'll be doing for now on with OPeNDAP, as well as developing some software. This, just want to show this slide, a little bit of what type of data we're going to access. It's not all NASA data, but we're going to access some NASA data. So I want to make sure that people, I think I wrote it as a requirement, but I want to know, maybe show of hands, how many people have an account with Earth data, like if you guys go to the Earth data login. So that's a good number. That's good. One of the things we're going to work with, maybe we can work with groups, in groups. So you definitely have time to get an account. It's just more of that authentication. So for example, we have the ECHO data set. So I'm an oceanographer, so a lot of the data here is geared towards oceanography. I apologize for that. But it's not about the oceanography content. It's just about accessing data. OPeNDAP is all about accessing data and subsetting data in many different ways. This is just an approach that works really well with the Binder environment, which is Python. We're going to use PyDAP. I'm not sure people have used it before. And we're also going to integrate that with X-ray, and because it integrates really well with the Pangeo tools. I'm a big X-ray user and developer as well, a little bit of that. So some satellite data, ECHO4, which is kind of like an interesting data set I've worked myself with. And CMIP6, which is on, I believe it's on the ESGF server, which runs threads, not even hierarchs. We had OPeNDAP run with hierarchs. But I mean, this is all about open access, open science, open software. So we're actually going to work with data from DAP2 implementation with threads. And again, this is just kind of like an introduction. I don't expect anybody here to be like really develop into this really powerful computational scientists or something. But yeah, so a lot of introduction. What kind of also what OPeNDAP is. Maybe show of hands, I'm sorry about this. People have heard of OPeNDAP before? Okay, it's a good group. People use OPeNDAP? which is a different question. I see less and less hands. People you heard of Hyrox? Okay, that's great. All right. Yeah, that's good. And then I actually, one of the things I'm interested in is just, I'm kind of new in OPeNDAP. So one of the first things that I did was, okay, for myself even, as a scientist, is like, how can I find kind of like URLs, OPeNDAP URLs? So I spent some time browsing the internet for those. And I think that's one of the key cores of fairness in any type of software. So I think we're going to do a little bit of that. But again, we don't have a lot of time to go through all of that. So let's see. So here we are. Maybe can you guys check who has a computer if the binder has already built, and it should look like something like this. So I clicked the button, it went to my browser, did something, and you can, for example, go into this binder notebook, and there's 5 notebooks there, Jupyter notebooks. Maybe can you guys raise of hands who has that at that stage? Does that mean that from your browser, does that mean that it's still running? Yeah, we have time for that. So.
Actually, can you go back and show them the URL? You know, the top of the screen is obscured.
Yeah, that's right.
So is there a way to make that upper section go away?
Okay, great. Thank you. Yeah, thank you so much. Yeah.
Just type in github.com/OPeNDAP/T62024.
Yeah. And please, also the people on Zoom, yeah, just you can maybe write a comment or a question there if you're having some troubles accessing this URL. This is just going to take you to the GitHub, and then there you will find that button called Launch, and then you click on the blue part of it, which is Binder, and that should trigger the entire build. People who are really interested in maybe doing a little bit on their own hands, and they have experience, you can just download, clone the repository into a terminal, and then just install and activate the environment, and just run it on your laptop. Actually, it'll probably be much faster to run these notebooks, I mean. So I'm going to kind of continue going forward because we have time for that environment to run. But if you're having technical difficulties, do let us know. So James is over there in the back, and I'm looking at you, so you can always just maybe raise your hand if you're having some trouble. Again, the purpose of this is for us to get a flavor of OPeNDAP through Python interfaces, which is PyDAP and Xarray. Same thing for Zoom people. I'm going to leave it here for maybe maybe 1 more minute. And again, just for the people who entered the room, I'm Miguel Jimenez. I'm a scientific community director for OPeNDAP, and I'm a computational oceanographer by training, whatever that means. And then I work with OPeNDAP, and James Gallagher is the CEO, so in the back helping people. And I think the goal of our session is for us to develop some knowledge and some understanding of the OPeNDAP protocol, which most of the times was working in the background, but how to exploit it. And we're going to focus a lot on Python and as a language. It's not the only one. You can also use MATLAB. You can use Julia. I've used Julia a little bit in the past, mostly for my own research. You can also use the browser as well for downloading or subsetting data sets. And we're going to go a little bit through that. But for the most part, what I'm mostly interested in as a goal for you guys, and we're going to state the goals in a bit, is to get a little bit of some experience with OPeNDAP via Python. Okay, well, So while James is helping people in the back, I'm going to show some slides. This is not the main goal of this session. It's just for maybe talk a little bit more while you're getting your environment set up. And also, if you're having some technical difficulties with your computer, your internet connection, we do encourage people, if they want to work in pairs. I think there's plenty of time to go, each of you, through all of the notebooks. And we're going to make those notebooks available as well for later use on the GitHub repository. And we also have a new website, which we're going to show a little bit towards the end. So in the meantime, I'm going to have some slides just talk a little bit about OPeNDAP, what it is. Some people think of it as more of a company. I really think about it as more of a open source software. It follows kind of the client and server model, which means that probably and most likely, just like myself, people use OPeNDAP mostly to access data, but I'm really a big fan of using OPeNDAP to serve data. Really, you sampled your data and you make it available. And that's kind of how it started. OPeNDAP as a server and as a software in general, it started about in the 90s as a need for PIs to share data between themselves. Because there were not really there were a lot of barriers, institutionalized barriers for PIs to share data with other PIs, even when they were in neighboring institutions. It started mostly within the oceanographic community, so a lot of the data that's out there is mostly oceanographic character, also some atmospheric sciences, but it's just more general than that. But that's kind of like how it started. This need to share data between PIs, between scientists, data democratization, it's all about without these barriers, which I mean, 30 years later still sounds like it's still the same problem sometimes. It's just now bigger and bigger data sets. But that's how it started. So it really is about accessing a tool, but also for serving your data. As a scientist, I think that's really powerful and really implements this vision of that they have. James was here in the beginning, that they have a bit of like a URL, HTTP URL equals a data set. You exploiting the internet, the capabilities of the internet, to just share data, just that. You have a URL, that equals a data set. And then now, a URL plus a constraint, that's a subset. So URL and then question mark and then something else, that is a subset of it that just get the data that you only the stuff that you really want. Do not download the entire data set. So I think that's great. And it's because since the beginning it was based on the netcdf format. It's really, really flexible. You can create your own classes of types of structures. We're going to mostly talk about array data, like satellite data, but it really can be something more than that. We have tabular data, structures, and then it very highly customizable into something else. Again, it's open source. And again, it's one of the big key issues about, great things about OPeNDAP is that since the beginning, they were able to have this vision of separating the actual data from the metadata. And that allowed what we call now lazy access. Essentially, you have a URL, you don't want to download the entire URL to figure out what the data is describing. You can just look at the metadata, the stuff that describes the data set itself. So people like myself that are oceanographers sometimes go on a boat and they're collecting samples on the boat and they have to record the environmental climatological conditions that were, if there were some sampling errors, something failed in the instrumentation, all of that kind of stuff goes into the metadata. Who created data? If there's some citable source associated with that data, all of that type of metadata, it was used to be incorporated into these data sets in a CDF file format. And now it's all CF compliant, which is a great thing about OPeNDAP as a tool. And over the years, there's been essentially two implementations. I'm not sure people are really well familiar with the different types of OPeNDAP implementations. We have DAP2, which was kind of like the original implementation that came out. And now we have the DAP4. Not all servers implement DAP4. At DAP4, really generally, my understanding of this is that it implements the netcdf4 format and broadly the HDF5, essentially kind of like the characteristics. It essentially allows groups and that type of behavior to go. Whereas DAP2, they have other stuff. They don't have groups, but they have grid arrays. And the CMIP6 is actually, the data set we're going to show is actually DAP2. And this is an example of how to access just the metadata of a data. So you have the URL, and then you just append .html. onto a browser, and you see all of this information that describes the data set. So we're going to kind of do that later. Same thing with DAP4, but now you add that DMR. That's really the only difference. And so this is what it looks like. You know, you have a URL, and then you append .dmr.html, and then this is the DAP4 data response. So this is that kind of like the CF compliant information that you see of a data set. This is what will look in your browser look like this. And it has, you can download data directly. You have a couple of buttons there, types, data file format. You really don't care what format you want. Like OPeNDAP deals everything for you. You just kind of specify what you want, the subset of what you want, and then you can actually interactively select the range of values that you want. And index space, I think DAP2 implements the GeoGrid, which allows you to actually pass range of latitudes and longitudes. I don't think we're going to do that, but you can do that later as well. And then just select what variables do you want, and then download them to yourself. But this separation of metadata from data is what allows a lot of clients and libraries like MATLAB or Python to read lazily objects that are remote. We hear that a lot now, lazy. This has been implemented since the 90s, thanks to like all of this software that's available. It's nothing new. It's just something that gets used a lot. And again, it's interoperable, so different types of data file formats, very extensible. People can always write a data handler if they want. It's open source. We welcome contributions for people who want to contribute. This is all open source software. And a lot of people in MATLAB use it a lot. Pangeo, like I'm a big Pangeo user. With Xarray, we've used it a lot. And now the people have NASA OpenScapes and Earth Access is also using this kind of DMR components of OPeNDAP. A lot of that in the background, the user doesn't really need to know, but it's there. And we want you to know that it's there. I think that's one of the goals here. And it's broadly adopted. Again, NCAR, UCAR has used it. A lot of institutions, and again, atmospheric oceanographic research institutions have used it. NOAA has their own implementation as well, both AirDAP and threads, and some NOAA people also use Hyrax. It's all like really works within itself, really well. Columbia had with the IRA, the Climate Data Library, and NASA, of course. Domain neutral, and it's really easy to deploy. For example, Hyrax, you can just run in a Docker to serve your own data. I think that's important to empower the people, the scientists, to share their own data. And again, because it can be many different types of formats, and it's all free, then you can serve your data and make it available for publications, for example. If you want to facilitate the review process of your science, get some free software like OPeNDAP and serve it, get the URL, and then pass it to the reviewers. Just a thought for people. All right, so here we are. Again, back to this slide. I want to show hands, maybe people who were able to get the Jupyter Lab environment going. Okay, that's a good number of people. People who still have trouble, we can help. We also, again, we can still, we want people to maybe talk to each other, to your neighbor, get stuff working, and then work in groups. We will have time to go through them, but I think it's good for everybody to see what's going on. And I'm going to run a notebook, so I think the goal for this is that we all go through at least one notebook together, because it really, all of the notebooks depend on one. It's called Get Started. If you're already looking into the binder environment, we're gonna do that notebook together, and the only requirement is that you have an Earth data user profile, because we're gonna access not only NASA data, but we're gonna access NASA data and require some form of authentication. So maybe show of hands if people who do not have an Earth data account. Okay, so you can go. So I think this is what it would look like. I already kind of created mine and then access. So we only gonna need something from that. Maybe people in the Zoom, I'm gonna, let's say maybe give it a minute or two, and then just to wait until people have their Earth data login. The only thing that we're gonna need from there is the token. So people who are already there, just make sure that you have a token generated. It's expire every, I believe 3 months. You can create one at any time. This is what it would look like. I'm logged in. Please go, if you can, to your Air Data login account and go to generate token. I generated one recently, so it's still some still have time before expiration. Let's see, and then what we're gonna do is go into the Binder environment and go to the Get Started notebook. All right, so I think mine's been open for a while. So I think I'm gonna have to get the URL going again. Let's see if it, I'm gonna try to open it before trigger the, yeah, and I think that happens sometimes with Binder. I'm gonna close this and then trigger the build again, and that would buy some time for the people as well. It should take about a minute, maybe less. And then again, for people we're here, just the only thing that you're gonna need is just to copy without need to show your token. I don't wanna show you my token. So we're gonna do that, and then my environment is already built, so it should be there already. And we're gonna do this Get Started notebook. Essentially what it's gonna do is gonna take that token and store it locally into a JSON file. And then every notebook that accesses NASA data is gonna read that token without you actually having to copy paste into it. So again, the Get Started notebook, we're gonna do this together. So I'm just gonna go and do the steps. If people are not familiar with Jupyter Live environments, do reach out to your neighbor or to one of us, just raise your hand. I'm kind of assuming a lot of stuff here. You don't have to be have a lot of knowledge of Python. Most of the code's already written for you, but there's some little bits of exercises there, and so maybe towards the end of each notebook. So, but yeah, please do reach out. So this is what a URL looks like. So something I can do, for example, is to copy paste. Actually, maybe, yeah, I guess I think I'm already, this should work because I'm already logged into Earth data. So I'm gonna copy paste this URL, if I remember how Microsoft works, and then paste it into that, and then append a .dmr.html. Enter. Let's see what happens. There it is. Metadata, all for you. Here's the URL. You can always copy it. I mean, I already had the URL. This is URL equals a data set. And again, you can scale this. You can have many, many URLs and then you can interactively modify, add constraints to that data, to that URL by just selecting, for example, variables that you want. And then automatically, let's say if I want time, longitude, dimensions, it's all CF compliant. And then let's say I want something that is many dimensions. So then the URL gets a little bit more complicated, but you can always just copy the URL and paste it into an OPeNDAP client, and then you will access that data. Anyway, so go back to our notebook. So we're here, and then this cell number 3, I'm gonna execute it, and this is where I'm gonna paste my token. So important that you're already, so you go back into the Earth data login, and you can copy here. If you can see my screen, there's a little guy over here, clipboard button symbol. Just press it, gets copied. There's fancier ways to do this. Chris showed me this yesterday, but I figured maybe just to make sure that we're all together in this. This is not an advanced tutorial. So Shift Enter and then copy, paste here, token, enter. Now you can see it. I'm gonna change it later. And then you can create a session, a Shift Enter, and now that session has all of the authentication required. And now we're gonna use PyDAP directly to access the data set. You can use PyDAP. What's great about PyDAP is it's a backend of Xarray. It might have been one of the early ones. It's been there for a while. So whatever you can do with PyDAP as a client, you can use Xarray for that. Yes? Yes, so to execute each cell, you have to select the cell, just the cursor, and then Shift Enter to execute that cell. That's how this Jupyter Notebooks environment work. So for example, cell number 1, that's to import the packages. Each cell just do shift enter to execute it. And it's important at this stage to do it in order. All right, so my token there, I have my session. So now I'm gonna just access that data set with PyDAP. And depends on the internet connection, it should take about 1 second or so. In my computer, it takes much less, but it's just, we're all here. And so PyDAP, I've been working a little bit with PyDAP myself. If you have complaints, maybe don't tell them to my face. I'll take it personal. No, that's not true. No, but you can reach out to me on GitHub, like please do raise an issue or something. We want people to get more used to PyDAP because, again, it's the back end of Xarray. So with the data set, we wrote this kind of like method that allow you to see what's in there into that URL. So you just do data set is the name of the object in this case. And so you .3 it also almost works like the terminal. So you can see every variable and you can actually access the metadata already. No data has been important here. It's all lazily evaluated. No data has been downloaded. That's why it was so fast. So you can see each of them. So for example, you can see, okay, what's the surface temperature? What's the size? What's the metadata associated with it? Which is field value. Sometimes they have offset, scale factor. They're all CF kind of like conventions. I have a raised hand, yes? They're similar, yeah. In this case, it's a type of PyDAP object, yeah. But what it does is that Xarray knows how to parse that. And so essentially, whatever I call the data set here, and we call it a PyDAP. Actually, you can create interactively here. So for example, type data set. It's just something particular to PyDAP as a model, but Xarray can understand that. And so you can see the size of it is fairly small. Anybody who's familiar with ZAR and chunks, typically you want a chunk to be a couple hundred megabytes. This is what it is. So typically in the world of ZAR and Xarray, scalable computing, you want chunks about the size of one netcd file that it gets produced roughly. And this is uncompressed because I'm estimating the size as if it was purely NumPy arrays. That's uncompressed. Really, the data set is compressed. If you download it, it will be much smaller than that. But it's just, again, it's kind of like this idea that all of these tools are being developed continuously to serve the same people, the same data, and we want the same similar encoding. All right, so this step is important. We want to store the authentication locally. So that was cell, I think, I changed the number, but it's under activity. So now there should be, if you're able to see a token.json file, then that means that you create a file and all the identification required for you to run all of the other notebooks is there. So I can just check that I can, again, open that information, that file, and then use that information to read a data set, and it's the same thing. So if we all finish this notebook together, then you can all run all of the other notebooks now. You can just go ahead and run any that you want. We have 4 to choose. I'm particularly going to finish this notebook, and I'm going to open the notebook called Echo, because I work with Echo data myself for a little bit. But please do free each other to pair up, or if you want to just go through all of the notebooks, there's some little exercises. You're not required to do that, but I think it will help to brought into some information. The CEO of OPeNDAP says you have to do all of them. Yes, I see one raised hand.
Yeah, I'm curious how OPeNDAP and like the URLs that you're using there, how that would relate to identifiers assigned to a data set, like a DOI or something.
Oh yeah, I see.
Integrated.
Yeah, that's a good. I think that's part of the CF conventions. So when you go to a data set, so I think I did. Yeah, actually, I have one right here. So this is a data set from NASA. This is a data response form. So this also has all of the metadata that describes the data set. And usually, for the most part, if you go to global attributes, there's a lot of information.
Can you say that
Oh, yeah. Yes. So the question was, sorry about that. The question was do we have a data URL and how does that relate to information about the person who created that data set, or if there's a DOI involved, associated with that data set. So that question related to that, I didn't phrase the question exactly, but I think the appropriate answer in this regard to that question is that usually, and from my experience, that information arises in the metadata that describes it, and you can access it directly on the notebook. If you just do dataset.attributes, you will see the same information here, but it's part of CF convention. So you usually, my experience that, especially a lot of data sets associated with NOAA, for example, they don't release that data set until it's been published. So if you go to NOAA data sets on thread servers or hierarchy servers, you will find the citation for that data set there. Yeah, that's kind of like the part of it. So in this case, we might find something here, but I'm not entirely sure. Right, well, yeah. With Symantix, we will find it. For this one, it was produced by satellite L3C product from GeoS 16. Yeah, so a lot of that. Yeah. Anyway, so yeah, please do go and again, questions are welcome. And also, I encourage you to just go through these notebooks. This is the part of marks the end of my talk time, but I'm happy to for sure answer questions from the Zoom people as well.
Yeah, this maybe is more of a NASA question, which is embarrassing for me as a NASA person. What's the advantage of using the generate tokens approach versus the netrc URS credential approach that I've seen? That's
Yes.
typical way that we do things.
Yeah, that's a good question. I'm going to repeat it for people who didn't hear that. So this is about NASA authentication approaches. So we use tokens and this tutorial notebook, and the question is, how does that benefit or compare to the approach of using netcrc files?
Netrc, yeah.
Netrc files, which I have used once, I think. So I'm not familiar with what type of information those files have inside. If they have token information, it should be the same. So I know that a previous iteration did not have token, have username, password. So that has a difference in terms of performance. So with username, password, it's much slower because there's many redirects that the user doesn't know about. So every time you try to access a chunk or something there's so many redirects. Yeah, with tokens you don't have that. Well, I think maybe you won't notice if you're just doing this notebook, but if you're having a production scale, then you will. Another question?
Yeah, so you mentioned that you had to do searching to find these. Oh, yes, of course. You mentioned that you had to spend some time searching to find these URLs. So what is how are these URLs presented? Where do people generally find them?
Yes, that's a really good question. It's not an easy question to answer. I'm going to repeat it. So we're talking about the findability of data sets or OPeNDAP URLs. And that's always a struggle. I'm not going to lie. I did spend some time. And so the question is how do you find them, essentially, right? So it really does depend on the organization or institution that it's serving this data. The data set with NASA and NOAA, this is a little bit simpler to do. NCAR, the same thing. Regarding to these tutorial notebooks, what I did when I started with OPeNDAP was just broad search. What is out there? I was really interested beyond NASA and beyond NOAA, which was the stuff that I was familiar. I did a lot of Google search. Once you find one URL, they're usually attached with catalogs. I wasn't familiar either with the ESGF, the grid federated they have they host massive amounts of data sets there. That you can navigate through a catalog as if you were in a file system. It's not easy. It's not, but to get started with finding these URLs, because as an organization ourselves, we have no control most of the times of how these URLs are being how they're being publicized. I guess that's the right approach. With NASA, it's much easier. They do have the DAGs have a lot of ways to access the data sets themselves, and you can find. So I can actually recreate what I did with NASA if people are interested. It's fairly simple. I know the open access or data access have their own way to find data sets, which is a little bit more interactive on the command line. But I do see that I think you want to have a follow-up.
Yeah, I guess, are we working towards like standards across kind of organizations on how to present like OPeNDAP catalogs and things like that?
Yes, thank you for that. Yeah, so essentially the question is there a way, are we working on it? Is there a way to improve upon what it's currently there? And the answer is yes. I'm particularly interested in this approach. It's hard to get these URLs that are, you can think of them as static, but they're not static because they depend on the people who are serving the data to make sure that those URLs were working. And so that there have been iterations of OPeNDAP having catalogs and catalogs in other organizations as well, where they list the URLs there. And then there's not communication with the data provider, and those URLs are still there static, but they stop working. So one of the things that we're involved here that I'm taking the lead on is that I'm particularly interested in having some sort of like CI, continuous integration with maybe with GitHub or something, in which we have ways for continual testing of URLs, like requests, if it comes back as okay, that means that the URL actually is working. So have a list of URLs in some form of document that is associated with our website, that lives there, and that is running with GitHub some form of Travis continuous integration, that maybe every week, maybe not every day, it's checking that all of these URLs are active, are still there, and that we also create a system, and I think that's probably my pitch to OPeNDAP is to do it through PyDAP, but we'll see that actually. But essentially have PyDAP or some other Python client, which is a standard common for practice for Python packages, to list data sets that their software can work on. That's a standard practice. So essentially allow for people who want to serve their data, if they're not massive providers, maybe it's a scientist who wants to advertise their paper and the data so that people can represent. So, okay, do a pull request or contact us, and we will list your URL there with a description, accurate metadata description for that data set URL, and that URL will get tested at least once a week. So I think that's one approach that we're working towards right now, and I think we're definitely interested in ways to make that, improve upon that. Because again, there's been several iterations, and I think that the fact that there's sometimes the organization that serves the data stops using OPeNDAP or uses something else, but there's no communication. And the idea behind pull requests from the data provider or someone who's interested in serving their data is that there will always be a connection with that person. If there's a URL, you know who posted that URL. It might work maybe for the next 5 years until there's something else other than GitHub or something. But thank you so much for that question, because that's something that's been on my mind as a scientist. And like I mentioned earlier today, I'm interested in scientists serving their own data to facilitate the review process, that's a big part of what I'm interested in. So I see people are still working on notebooks, which is great. If you find a problem, do let me know. You have a question, raise your hand. We can approach you as well. Same thing for people on Zoom. I see a question.
Hi, Suhong from Deck. For accessing one data file through OPeNDAP, it's quite easy. But is there any, what's your recommendation if I wanted to access, a long time series of data?
Yeah, that's a great question. The question regards to how easy sometimes it is to access one URL with OPeNDAP. How about many URLs? And I think that's the power of the Python clients and the software. Right now, OPeNDAP essentially accesses one URL at a time. That might change. We're working internally, and also the virtualists are people. I have to acknowledge the people behind Earth Data Access. They're working and doing some more improvements of that. At the very least, you can always use Xarray. Like I mentioned, PyDAP is a back end of Xarray, which means that it's recognized as a backstore, as a backend. So you can have a list, and actually one of the notebooks here uses Xarray to access. I think it's the Echo notebook that I am showing here. You are able to create a list of URLs, it's not it doesn't work as nicely as with ZAR, that you have like the asterisks, which is maybe we'll work on that in the Python and the PyDAP end. That's something I'm kind of interested because that's really nice behavior. But you can always create a list of URLs and pass them onto Xarray by defining engine equals PyDAP. Again, the Echo notebook has that particular example. And you can actually pass constraints into that URL. So it's using Xarray for parallelism, but also employing the hierarchs powerful of subsetting. So you can actually combine the two of them in parallel. I'm not sure people are aware of that, but I think it's cool. So here it is. It's part of the kind of activity of the Echo notebook, that you can create a list of, say, for example, you want to create an object, a remote, for the points to a remote list of data sets regarding temperature and salinity for the Echo data set, to at least 12 of them, but you can go all the way to 1992. And you can use Xarray right here. And I actually worked with the Xarray people many years ago to implement some aspects of multiple data set as a client. So again, we're all working together. We're all working to create data democratization, empower the people, and to kind of improve upon the workflows for the current needs. So while people are working, I'm just going to talk a little bit about this Echo data set. Just this notebook, I'm kind of passionate about this data set. I've worked a little bit on the Echo data set myself as a modeler. It uses, as a product of NASA, you can actually find it on the NAC. So I put some links here. So let's see if I do this if I do this. All right, great. I haven't used Windows in many years. So some of the URLs, some of these are clickable and at the top of each notebook. So you can go to the PODAC directly. This is the information for this data set. So you can always start from scratch. Let's see, let's find some data on NASA, you know. I'm already logged in, so I shouldn't have a problem. In this case, this is one of the easiest ones to navigate. It's a really nice interface. But let's say I want to find different types of data, but I'm particularly interested in an Echo data set. Let's see, so there's Echo, there's 90 products and the projects, so Echo is a project, so I will click here, go to project, and you have 90 results. The interesting thing about this is that the Echo data set is as a model simulation that was run on a cube sphere, which essentially means that it's like orange has been done into square cubes, but they all have different sizes. But the topology is kind of complicated. So people that, when I was still at Johns Hopkins, with people with like the Pangeo project, some people at MIT and Columbia were involved. We were trying to build software to improve built on Xarray, of course, to facilitate the analysis of it. And all of this data can be accessed via OPeNDAP, by the way. So it's open. So here you can find it interpolated, which is good. People who, like myself, are oceanographers, we're sometimes interested in data that is not interpolated, which means that you have to deal with the complexities of the grid. So you can find non-interpolated data set here. So for example, you have sea surface, so temperature, wind, so you can click here. And we're gonna find some OPeNDAP links here. Right, so here's the information about this particular thing. I think this is the grid, even though it says, or maybe it's just on the grid. Okay, so here is this daily average atmosphere surface temperature, humidity, winds, sea surface forcings. Let's say, how do I find that OPeNDAP URL from here? Well, I would go to data access. And one of the great things that you can actually go to CMR for direct access. A lot of the stuff you can do in the browser, but let's say if I want to get the actual URL, there's other ways to do it as well, but I'm just doing the most clickable ones. So there's some years here. So again, this Echo simulation is assimilated data from different sources that's run into this grid with very low resolution. I actually work with the LLC 4220, which is petabytes of data. In binary, by the way, which was really fun. And then so you go to the latest year, 2017. You go to the first month. It's all clickable. I'm just doing that. File count. This may be the daily one. Yeah, that's right. This is the daily one. And here and before, You get other links. You go to OPeNDAP for other links. This is how I found most of my NASA data, by the way. And again, there's probably more efficient ways to do it, but I kind of like the clickable ones, and we want to have different ways to access the same data set. And here we are. We have a URL. I can just copy raw. I can also create some constraints into that just interactively. Like, for example, this is daily. And let's say I only want one variable here, and just one of them. And so just by clicking on it, you've created the URL already for that data set that will only contain that variable. You can subset. Let's say you only want 10 grid points, then you just modify here, 10 grid points, and you've interactively created a URL that will only download that subset. I will do it differently. I would do it on the command line, but this is a great way to make it easier for people to use OPeNDAP with your favorite client. You can use this URL with constraints to get a remote data set somewhere using any client that you want that takes an OPeNDAP URL. It doesn't have to be PyDAP. It doesn't have to be Python. You can copy raw data URL. You can just copy the encoded one. The encoded one is important because we're talking about the browser. So if you just put a OPeNDAP URL with a constraint, if that constraint has square brackets, it will fail. PyDAP deals with that for you, and ergo Xarray deals that for you. But you can just copy the encoded one, okay, and then just paste it onto your browser, and it will download your file. And again, subsetting in index space, I wouldn't recommend with a native grid here because the complex topology of this data set, and that's part of the notebook. So I encourage you to play with it. I can just, actually, if there's no questions, you can ask any questions at any time. Same thing for people on Zoom. There's 3 of us here to help. And so in the meantime, I'm just gonna show you why that data set looks kind of weird. And that we spend many, many months and developer effort, including myself, to write software so that the person analyzing the native grid wouldn't have to deal with the complexities of the native grid. You can just sample it. I was going to put it in a notebook here, but I thought it was too specific for oceanographers. But if people are interested in learning more about this software, you can tell me. Software that I developed with the Tom Hain group, Johns Hopkins. I'm still actively involved with it, and we're still, within OPeNDAP, we're still collaborating with that. Again, OPeNDAP as a tool for subsetting, Xarray for scaling, and then we have the Johns Hopkins supercomputer system there with brand new Kubernetes to scale. I think that's a great combination. So this is what it looks like, the grid many files. I'm just gonna keep running this notebook, all of this stuff. And again, the complexities has to do with, actually, let's just plot it. Okay, so one of the cool things about it is I've talked about lazy access. Okay, whatever. What if you do want to plot something? Well, you probably do want to download something into your computer. And that's where the idea of chunks helps, because you don't want to load the entire data set. There might be multiple terabytes of size. You only want to download one chunk. In this case, each chunk is essentially one file, one netcd file. So we can load it, and PyDAP, the way it works, and this is syntax that Xarray knows already, and slightly different, but for PyDAP, you can download data locally by having this bracket and then this colon, semicolon or colon? Yeah, sorry, I'm from Mexico, sometimes I confuse them. In Spanish, it's a little different. Dot and comma, that's what we call it. So with this, in 4 seconds, it downloaded depth as a variable. So that variable is already in memory. It's probably, let's see, what's the shape? Attributes, field value, let's see, CF compliant, has a checksum, that's important. The variable depth has 2 coordinates, XC and YC, which essentially in this case is just latitude and longitude at center points, which are scalar variables, which just means they're not a vector field. Original name, some comments. You can look at the shape, even if it's a 2-dimensional variable, and this data set is 3 dimensions, because again, you have to take an account into the idea that this cube sphere has been divided. The people here call it tiles, we call it faces, but it's all the same thing. There's 13 faces. You have the Arctic, it's just face or tile number 6, and you have the one side of the world, it's all has a normal orientation, which means that U points east and the I index points in that direction, and the Y index points north. But if you go to the other tiles, it's backwards. So getting the curl is always fun. So let's see, let's plot it. It's really easy. I created all the plotting functions for everybody here, and just for visualization. And this is what the native grid looks like. So if you're gonna see it, maybe in 2 more seconds, this is just plotting the data. This is what it looks like. That's, you got the Arctic and this kind of like at this over here. And then you have Europe, Africa, Asia, some part of Australia has a right topology, and then the US. So now the U vector points south. So you have a U that is positive value, it's south transport. But it's just, again, it's just this projection of having a sphere project into a plane, which it's not one-to-one, so you have a Q sphere. So these data set, one of the things is a NASA product. It's still widely used and still going to continually being used for machine learning aspects. I've read some really nice papers recently, both from the Python world, Pangeo, but also from the Julia, the Clima. They're all essentially, they're kind of like running this still for research purposes. And then you can correct. I created this plotting function that plots it correctly, geographically correctly. So you can always fiddle with this. My world is kind of centered around Asia and the Pacific Ocean, because I'm from Baja, so I like the Pacific Ocean. But you can fiddle with this a little bit, but you can see kind of like that each tile, what they're all about. That didn't fix it's just for plotting, that didn't fix the grid topology. I see a question, yeah, one question.
Thank you. I'm curious about this from a research reproducibility standpoint, and I'm curious if you have seen any good examples of, for example, like a publication package that includes the paper, the OPeNDAP URL, and a notebook like this to help people really go through others' research.
That's a good question. So the group at Johns Hopkins that I was involved with, I know there's a lot of ECHO users for sure. And Johns Hopkins, we developed Ocean Spy, and I was in charge of taking this package to work with this type of geometries. So I might be that person at some point in the near future. Aside from me, I would check for the group there, the grad students there. They're probably still using, more actively doing research than me at this point. The Ocean Circulation Group with Professor Thomas Hain. I'm still collaborating. I'm still also developing still Ocean Spy. So I know Ali, the grad student there, did a publication with ECHO. I don't think back then we didn't know that OPeNDAP served that data set, so we have to download it ourselves. This is a much, much better approach. So they probably don't cite OPeNDAP, but maybe there's some pointers into the software. In terms of software, I would say Ocean Spy, which I was involved with. We're still finishing some stuff, and I'll be creating for sure. One of my roles in this OPeNDAP will be create interactive notebooks that access, particularly because I'm somewhat of an expert now on this data set, to have this example with this type of workflows. And I was actually going to include a notebook here, but I thought it was too specific. I want to keep it more broader than just oceanographers. But I will also check the OPeNDAP, because I'm going to be posting stuff there for ECHO, potentially LLC, the other type of geometry. Thank you. I didn't, maybe I should say the question now that I gave the answer. It was just about maybe some information, tutorials, or documentation that have this type of workflow that uses the whole production of OPeNDAP all the way to research publications that they describe OPeNDAP, X-Array, PyDAP, or some other packages. Yeah. And again, it's pretty oriented towards Python right now, but Julia is also another thing that will be very useful. a lot of the people who run the LLC type of geometry also are in Julia, so I would check it out too. I see another, yeah.
Hi, so I'm a data producer and I'm looking to make my data more accessible to people. And I'm coming from geophysics where we don't have any kind of, so we don't work with Earth data or NASA data. It's very like smaller data sets, but they can get very large, like multiple gigabytes. So I'm wondering, from my point of view, how do I get my data to the point where we can use it like what you've just shown? Do we need to have a server that the data lives on? And does that have to have special requirements? Does the data need to be, like we are working with NetCDF actually and building on the CF conventions trying to, so if we have our data in that format, is it really just we need the place for OPeNDAP to point it to link with, and then we can chunk our data and use it just like what you've shown?
Yeah, thank you. Yeah, the question is essentially, it's come from a data producer. They're interested in making their data available, and they're really interested in OPeNDAP as a solution for making data available. And they're wondering, how can we do this? I think the answer is, yeah, OPeNDAP will be a great solution for you. One of the great things about OPeNDAP is that, let's see if I include it here, it's really easy to deploy. You can use Docker, for example. I believe that James could probably give a better answer for me, because I mostly use from the client side. But again, I'm a big fan of the server side. I'm getting familiar with that. So I will look into Hierarchs and Docker. I know that a lot of the NASA stuff is also deployed in Docker, right? That's correct, yes. So Docker will be, and I've done it in my laptop. I serve data myself with Docker on a Mac M1, so that was fairly simple. So I got really excited about that. Again, as a scientist myself, I'm thinking of publishing and making data available to reviewers in a way. That's another way of a different, smaller scale than our attendee asked about how to make data set available through URLs. Yeah. Do you want to add something to that? There's probably more complicated stuff, but I would say some storage will be something to run the Docker. But if I run in my computer, just something that can continuously be turned on for people to find it. And again, this is the issue about URLs, in making sure that the server is running, that URL is not broken, it's something. And then, like I mentioned earlier, maybe talk to us so that maybe we can advertise that URL and come up with a system that also auto-checks the URL status. Another question?
Yeah, so can you deploy like an OPeNDAP server like in the cloud?
Yes.
So that you wouldn't have to serve it from your individual laptop?
That's correct. Yeah, so the question is, I already gave the answer. Sorry about that. The question is, can you deploy OPeNDAP server in the cloud? The answer is yes. Hierarchs can be run in the cloud. In fact, a lot of NASA runs Hierarchs on the cloud already. There's a lot of instances. Yeah, so I think all except the PACE data here in these notebooks are run on the cloud.
Okay, thank you. And then is there a recommendation to have, like, and I'm curious how NASA and NOAA are doing things, like, do they have a single OPeNDAP server or multiple? Like, do you have to have very standardized data sets all within a single OPeNDAP server, or can it host very diverse data sets?
Yeah, that's a good question. So essentially the question is about how, if I understand correctly, like, is there any requirements in terms of the data in order to, how many hierarchs, how many instances do you have to use to deploy this data, what format, or what kind of the requirement in terms of the data aspect of the, sorry, I was already thinking of the answer when I
Yeah, I guess I'm wondering if the best practice would be for individual projects to have their own OPeNDAP servers, or if it should be at a higher, more aggregated level within an organization. Like, so I'm from US Geological Survey, and wondering, like, if we were to stand something up for anyone at USGS to use to distribute their data, is that possible? Or because our data is so diverse, would that not work? I guess,
Yeah, those are really great questions. I think I can answer them, but you should help me a little bit on that. So the questions were, so this is about like should a server maybe set up for a group or for the entire organization, how we do this. There's a wide variety of types of data, not just data formats, but just terms of types of data. What are the best practices in terms of, for that approach? I think the answer, part A of the answer, which I'm gonna let James chime in as well, but I think that it's up to you probably. I'm thinking also as a scientist. The way, for example, think about like NASA has different DACs that serve different types of scientists. So if you're part of an organization that has many different types of disciplines, then you, in a way, would kind of be up to you how to best serve the scientists that want to use your data. Either way, OPeNDAP can be set up. It's more about how people will be able, easier for them to find them. You can certainly run them within your group, within your, if you're a PI, you can definitely, like PIs get money to get like compute servers and something. So you can definitely set up a server or in a cloud instance if you have a budget for that. If that serves best your community, that would be great. But you can also use it within a larger organization, depending, in many ways. Those are options. It'll be up to you and your group and your collaborators. So yeah, maybe you want to chime in. In terms of the variety of data, I think it's very flexible, OPeNDAP, in terms of data formats and types. And because it's highly customizable. We're mostly showing array data. It can serve tabular data. It can serve nested structures, which have very broad, kind of very complicated structures within themselves. Most people access satellite data, which has a pretty simple, but it's pretty flexible in terms of that. And then,
Yeah. Well, there isn't too much to add to that answer, but I was pulled up here. So there are actually examples of both scenarios that you kind of hinted at in your question within the NASA ecosystem. So we run one single instance cloud server that serves data from multiple DACs. And that's the server that runs in the cloud. And that server is fairly sophisticated in terms of its infrastructure. There's multiple compute instances, and they have in front of them a load balancer that spreads out all the requests that come in across multiple instances. And then as the activity on all those instances increases, other instances are pulled from a so-called warm pool and brought in online to deal with the increased demand. And then as demand ebbs, some of those are thrown from the active pool back to the warm pool. So there's that, and you can have that, and you have basically a full-time person keep that going. Sounds like it's all automated, but yeah, okay. And then also the individual DACs all run typically multiple servers. So there's 50 servers that run on site at Goddard Space Flight Center right now. And there were a number of servers that ran at the Physical Oceanography DAC at one time, but they've moved all of their data into the cloud, and they use that one big humongous thing that's complicated. As far as data variety, lots of different formats are supported, and it's extensible, so you can write code to add support for your own format if it's very much off the wall.
I have a question. So what are the benefits of hosting data like she was describing on an OPeNDAP server versus just hosting the files on Amazon S3?
I can think of one easy to answer is egress charges.
I'm sorry?
Egress charges,
okay.
I think. Yeah. Definitely. I think that will be the major one that concerns us. As a user, I mean, probably, this is an example, as a user myself trying to access, I wouldn't know, maybe. I might tell the difference a little bit in terms of performance, but then I wouldn't know much about the difference between an OPeNDAP server, aside from knowing that there's a URL. Other than that, I'm not familiar with like hosting data on Amazon 3 myself as a provider, but I know that this is especially for smaller organizations, medium-sized organizations, and some of the larger ones as well. I want to share a story that as a user, I was trying to develop software for analyzing petabytes of data, ALC 4220. And then I didn't realize that I ran through the egress charges of Pangeo for like the rest of the year, because I didn't know. It was just one user doing bad practices. So that was scary. There's probably better answers than that. And I can see there's probably an evolving answer, but I think it's a persistent worry for most data providers. And I mean, we've been around, OPeNDAP's been around for a while, it's been tested, and you can run it in the cloud, which manages, rather than moving data, it moves metadata around very efficiently, the DMR objects. And we're building tools to make that with Virtualizar, with the Pangeo people, and also with Earth Data Access, to make that scalable, much more efficient.
So,
Yes.
I had one question.
Oh yeah, sure. Another question
so,
from the tech person.
So, for repeating that or adding on to the question that was asked, because in my group, we work on something called as Texas Water Observatory. We have like 5 locations across Gulf of Texas where we collect data, but we are hosting it in AWS S3. So the question was, if we are going to sort of, let's say, switch it to OPeNDAP, is there an upper limit to which you can freely access it, or is it
Upper limit to what?
how much data you can sort of store it in that server? And because what happens is storing the data is not as costly, but if you put a dynamic component in it and people are sort of accessing the data, downloading the data and looking at it, that costs more. So how does it compare with OPeNDAP?
Yeah, let's see. So the question is about if there's a limit to how much data is there in a server and can be set for access, right? Is that correct? Like broadly, that's the question, right? I don't think there's a limit, no? I think it's mostly on your hardware limit or your resources limit to buy hardware. What I am aware of that there's a limit, and I put it in the notebook so people who are in the CMIP 6 notebook, they might see it as an error, is that the provider can set up a limit of how much bigger of a size of a request you can put. And that's the only limit that I'm aware of from the OPeNDAP side. Right, and those are hardware limitations inherently. Yeah.
Hi, Dane, do you still have a question? Your hand was raised earlier.
No, actually, I was going to try to answer part of the question, but James jumped in there and answered it. He knows a lot more about OPeNDAP than I do, but
Thank you. So still building on that same question. So if you already have your data stored in S3, and then you're leveraging OPeNDAP to access the data, am I understanding then correctly that you're saying that you wouldn't have the same level of egress charges from S3, or is that, or were you assuming that you would be storing the data on your local hardware?
Oh yeah, no. I think that was the question in terms of hardware. In terms of the cloud, what OPeNDAP does really well is that rather than move data when it's requested, it moves DMR documents, which it holds them at the data, kind of like the chunk references. So this is the integration that we're working with the Virtualizar people, is that we're creating this system in which OPeNDAP moves the files that hold information about where the data is located, and that particular subset of your data, like a chunk reference, to minimize, in terms of when the data is on the cloud already, to minimize the egress charges.
Okay, so this is going to maybe show my ignorance here.
Yeah.
But so Xarray you can use to access netcdf files, right?
Yes.
As a Python library.
Yes, yeah.
And can you use that to access them in the cloud? Because like, wouldn't you be able to use Xarray to get the metadata as well? And so would
Yes.
that, would
That's a good question. So I apologize if I didn't say the previous one. I keep forgetting. So the question, I'm going to say the newer questions, like this is a question about, well, Xarray can access netcdf files. It can definitely access stuff on the cloud like S3. S3FS, I've used it myself. With Xarray, you get a lot of random, kind of like random access. It doesn't really know where the data is. So it's not the most efficient way to try to access data on a netcdf format. With ZAR is different. I think that's one of the advantages of ZAR in terms of the netcdf format. With netcdf, Xarray can create a lot of random requests because it doesn't know where the data is located yet. With OPeNDAP, what it does is that the server itself creates DMR documents just running a command line, essentially. Every time you have a data set of many different file formats, it creates the chunk reference, the DMR document. It essentially contains information about the byte range, where the data is located, and what type of data or range of data is located within where. And so, can Xarray access data? Yes. Can it do it as efficiently as with OPeNDAP? No. But this is what I'm saying. We're all working in the same things. Yeah. So because of OPeNDAP and the MRPP kind of like technology or say software, it's going to make it much more efficiently. And there's already work happening right now on that. Yeah.
I have one more question.
Oh, yes, yeah. Tech question. Non-tech, but tech question.
So I use R more to access geospatial datasets. So my question was, just if you could elaborate what chunks and tokenization means in a layman term, because I'm not able to relate it as what I do in R.
So essentially you're asking me to
explain what chunks mean
right?
and
describe what chunk is. Yeah, I think. Yeah, so it's the idea that we live in a world where these data files themselves are too big to open into your local computer. Most of them, well, depends, but a lot of the data files that we now work with in geosciences tend to be many gigabytes uncompressed. And so you have, especially with netcdf, you have to open the entire file to access one value, for example. So that's just the model. A lot of these files are increasing in size to the fact that they're a full data set. Maybe if you want to do a time series, iterate over many files, you may be thinking about several terabytes. I'm not sure your computer, but if you're working on your laptop, you won't even be able to open the data set. Or if you do it in a for loop, it might take a couple of weeks. That's how I did stuff sometimes. And my PhD is like, it would take forever. But that's just this property of these data sets being massive, too big to fit into memory, I think. And so what happened is that we're starting creating these different types of API or like files, essentially file systems, in which you put the entire data set, but when you access it, you only access one single chunk of it. And that chunk can be, it depends on the type of approach, but in the modeling world that I come from, for example, you can test actually in terms of throughput or compute power what's the most efficient chunk you want, but you want a single chunk, which is the one that it's open into memory at a given time. You want it to be a certain size. From modeling standpoint of view, sometimes that's 100 megabytes uncompressed. So you can have an entire data set be one store or one file, essentially, one URL in aggregation, but then you're only reading one little bit of aspect of it, and that is a chunk. And you can change what the size of each chunk is. If it's too small, then it's gonna clog your work. If it's too large, it might not fit into memory. So it's always that part. And then how it relates to what I'm talking about is that the idea of chunks is not new. It's not inherent to ZAR. It's been around. netcdf4, for example, has chunks. It's been around for a while, no? And so when I think of chunks, I think of the piece of a data set that is read into memory. That's a pretty broad definition every time you are trying to do some analysis. So it works out if you aggregate many OPeNDAP URLs, one of them, I've been looking into them, it's about 100 megabytes or something. So it's kind of like one chunk. One netcdf file, it's one chunk, kind of, in terms of the way I think of an ideal chunk size for my approach. So it really, in essence, is just how much, what aspect of the entire data set you're able to read into memory at once.
Thank you.
So how are we doing? I think I've talked a lot. I'm more than I thought I was going to. 3:15. We still have time, I think, but maybe we start moving more towards the questions and reflection aspect of this tutorial workshop, right? I think that's what the timeline said. I can give a couple of minutes if people have more questions. You can always, the reflection is more about maybe describing what we did and maybe what we learned or what complaints as well. We did have an agenda. So I think the workshop goes from 2 to 3:30, right?
Yeah.
Yeah, so 3:15. Yeah, so these are all there. The binder lives in the repository at OPeNDAP. It's free for people to access it, to play with it, to modify it. There might be some typos. Please forgive me. I do that sometimes. But yeah, maybe let's go into, I would have loved to do maybe some more, but it just, time is always an aspect of these things that I'm not very efficient at. So why don't we maybe, we've been at Q&A, it feels like to me, but we can, maybe if you guys want to have more of a reflection, you are able to raise your hand. You have more questions, people from Zoom. And if not, maybe we can start moving towards the closing remarks, or do you want to talk about something else? That's also a possibility. We have the time. Yes, and just to finish my thought, again, most of the examples that I showed here was atmosphere, ocean side, some satellite, but mostly ocean. That is my background. I apologize for that, but OPeNDAP is domain neutral. So when we are interested in learning how, and we are aware of other people outside from geosciences that use OPeNDAP, and we're interested in learning how OPeNDAP is being used by other people other than oceanographers. So people in Zoom or people, if they ever find this on YouTube or something, do reach out to us because we're interested, for sure. And with that, I think there's a question.
Yeah, so I was just wondering, in the title of this talk, it says fairness with OPeNDAP. So were you planning on talking about anything about the FAIR principles, like for open data?
Yeah, so that's a fair question. Yeah, I think I put the title towards the end because I was thinking, I really wanted more people to get a hands-on experience with OPeNDAP. Fairness is something that we're working as a community towards. I think my experience, my personal experience, one of the hardest things about being fair is the findability. And that's something I tried to touch a little bit in terms of how you can do to find, which was not a perfect answer. This is something I still work on. And I'm also mostly interested in facilitating people to make their data and URLs visible. Not everybody wants to make those visible. So in terms of the fair aspect of it, that's one of the things that we're working the most and most interested in improving. And also with that in mind, we're also creating more places for people to find us and talk to us. We have a new website, we have a discourse forum where we just started. We're interested in getting more and more URLs to make public. And I mentioned a little bit one of the approaches we're finding. In terms of reproducibility, interoperability, I hope that in many ways that this workshop helped a little bit to see how, even though I didn't mention it, that's part of OPeNDAP already. We're able to deploy OPeNDAP as a server on many different ways to interact with many different file formats. It's highly customizable. It's open source. The fact that we can run this in a binder, and we focus mostly on PyDAP and Python really, but I used to be a MATLAB user, and so I did use MATLAB a lot for OPeNDAP as well. R, you can use R for OPeNDAP as well. The ArcGIS, I think that's one of them. I think there was another one that changed names, but I forgot the name. It's on the website, for sure. We're trying to have a website that contains useful information in terms of how to in a way implicit without overstating it, how OPeNDAP is trying to be more fair. And it's not something that happens overnight. We're definitely working on it. And I'm definitely interested in the part of making URLs more accessible, findable, and a way that makes long-term sense with having some sort of continuous integration, checking URLs and stuff. Yeah, thank you. Anybody did CMIP 6 notebook? That was DAP2, by the way. One of the interesting things about that DAP2, that's a thread server from our colleagues. Let's see. Oh, I changed something, and I don't know what I changed. But one of the interesting things is that DAP2 supports grid arrays, something that I found while playing with CMIP 6 data. And you can look at the metadata. Actually, I think there's a DOI there. I keep not clicking the right one. What if is that it supports grid arrays, and when you when you try to download data, it's actually really slow to download the entire grid array. But if you access it, just the variable that is listed in that, it's super fast. So a lot of people, it's something really frustrating in terms of internet connection, and then also sometimes it takes a long time. A lot of that is that a lot of data is on older servers. And so it's about kind of finding ways to make it more, here it is, faster to run. So the CMIP 6, I think each file was 80 gigabytes, the variable, each netcd file or something. That's kind of, I don't think you could open that. And I think my computer has like 16 gigabytes that you can read into memory. So not even one chunk, not even one file you could open there. But if you try to download, it takes like 5 minutes, this cell right here. So again, PyDAP allows you to have lazy access, just the metadata and the shape size of these objects, which again, XRA is using the backend. But then when you add these like brackets and colon, you actually bring data into your local environment. You download it and lives into memory. It doesn't download into a file, you just bring it in. But this line takes about 5 minutes. In my internet connection, so here would probably take longer. So I was actually curious if people run it. It might take 10 minutes, you know? But at the next one, if I just, I think the same thing, if I subset, it's probably the same thing, several minutes, because it's single file, the time unit, sorry. But then this cell right here, it's super fast. And the reason why is that if you do the tree command, and actually I can run it really quickly. I think that might be easier to visualize what's going on with DAP4. So there's a difference. And the DAP4 is a little older. It was 99 or something? 95? DAP2.
DAP2, yeah.
There was 93, so a lot of OPeNDAP servers are from that area. So DAP4 is much, much newer. So anyway. But what I wanted to show is that you have this URL, and then you have this grid type that has the variable and then it maps. So essentially, it's kind of like a netcdf on its own. Every time you have a netcdf, it comes with its coordinates. That's why it was like very compact and shareable. So I think if you try to do this, it's really slow. So I'm going to try to do just this one. So this one takes well, maybe it takes too long for. I think it takes like 5 minutes, but this takes seconds. If all you want is, there it is. Choose one variable, be aware that grid arrays you have to be a little careful with them. So that's a DAP2 implementation. So this should be much faster. Even with this internet, 2 seconds. The other one took 5 minutes. So why is that? So that's because if you do, so we're going to do the lazy part. Actually, I'm just going to write it here. If you do this, TS, what's in there, and then you do actually just the entire data set, because I don't think, so you want to see what's in there. TS packs itself and the dimensions. So just trying to download TS, it's going to be really slow. But at this level here. But if you actually try to access just the variable itself, it's really fast. So this will, the command of here, it takes 5 minutes on my computer. And when you look at it, it's a list. It's not an array, it's a list. And it's a list of 4 items, the variable itself, and the 3 dimensions. So just something to be aware. I think that's why the 3 attribute or method that we added, it's very useful to visualize. It's a visual distinction between kind of DAP4 and DAP2, the presence of arrays. And again, DAP4 has groups. I think Xarray doesn't have that yet, but there's work on that. But you can do groups with PyDAP really easily. Just actually, one of the notebooks, I think, SWOT data had groups, nested groups. Yeah, you maybe didn't notice, but it was really, really easy to work with them.
So, at this point, we only have a few minutes
Yeah.
left, like 3. So we might
Sorry about that.
So one of the next steps that we think people should do here, and I guess, for my 2 cents, so the next steps would be, if you have data that you're interested in serving, contact us. If you have use cases that for data users, again, contact us. Miguel said we have discourse, we have these new mechanisms to access, to get in touch with us. And also we have some YouTube videos. It turns out that people in and around NASA and NOAA, Jet Propulsion Laboratory at universities have been making these videos and posting them without ever telling us. So we found them after a while and we started putting them all together. But if you guys are doing that stuff, hey, add them to the collection. If you're interested in looking at what other people have done, come to our new website, check that out. If you have any questions, no matter their nature, just ask us. Yeah. We don't bite. Besides, we're mostly remote, so even if we do.
Yeah, and like I said earlier, I'm going to be posting a lot of material there with PyDAP, Xarray, and the stuff from, and I'm going to start working also with Julia. We want to make sure that OPeNDAP is not just, it's not really just a client, it's also software. So I'm interested also in serving my own data and see, how, it's really easy. I already did it, but it's just the entire production. I think it's going to be great for publishing as well. The review process is going to be really great. Thank you very much. Please talk to us again. And thank you for the people on Zoom.